Hi guys, welcome back. Today we're looking at, again, an application of the things that we've been learning with writing equations of lines and looking at how that fits with things like sequences and now today's scatter plots. So by the end of today, our two goals are number one, to be able to understand what a scatter plot is, be able to draw a line of best fit, and then be able to write the equation of that line. Most of this is stuff we've already done. We're just looking at it in a different context. Okay, so the first thing that I want us to look at is what is a scatter plot? And like we've said before, mathematicians are not super creative in the way they name things. So a scatter plot is just like what it sounds. Scatter plot is just a plot of points that are often scattered all over the graph. Okay, we might be plotting different kinds of situations, but it's just a matter of a relationship between the x and the y, plotting those points, and then looking at that scatter plot to see if we can figure out any sort of patterns. A line of fit, on the other hand, is does the information in a scatter plot look like it begins to form a line? Is there a pattern that we can find? Because if so, we're going to draw a line of fit showing that relationship. And then we can use that line of fit to help us predict what might happen in the future. So for instance, a line of fit might look like this. If I plotted some points, and let's say those points scattered to look like this. When I look at that graph, it looks to me like there might be a line that would fit right through that data. And so this line that I draw is what I call a line of fit. It fits the data. And I can write an equation of the line. I can't write an equation to hit every one of those points, but I can write an equation of the line and then use that to predict what would happen at different parts of the line. So continuing with some vocabulary, we've got the basic stuff, the scatter plot, what it looks like, and what a line of fit is. What we're going to look at now is what we call associations or relationships between the information. So I've got three words here: positive association, negative association, and no association. If I call this first graph A, B, and C, would you take a guess on which one, graph A, B, or C, is a positive association, which is a negative association, and which one has no association? So if you said that A is the positive association, B is the negative association, and C is the no association, you're exactly right. They're right there in order. And the way that we can tell that is a positive association as one x value. So as the x value increases, the y value also increases. So as I get further and further after sunrise, x value increases. I'm also getting higher and higher in temperature. So they're both increasing at the same time. A negative association, on the other hand, says as x increases, y decreases. So again, as you see along the x-axis, as I get bigger and bigger along the x, the y's get smaller and smaller. And finally, no association, it looks like there is no pattern. And that's exactly what's happening here. Some of you may be saying, just in case you missed what that bell sounds like, some of you may be saying, this looks like these dots have a positive slope. These dots look like they have a negative slope. And these over here look like they're just scattered, no slope detected. You are exactly right. And that's a way that you can consider and think about these problems in your work. So we're going to just real quickly look at these two, 1A and 1B. How would you describe the association of each of these scatter plots? I hope on 1A you said positive, and on 1B there is probably no association involved here. All right, so now we're going to begin talking a little bit more about the line of fit. or a trend line, as some might call it. This takes us back to that first graph that we looked at, the relationship between the hours after sunrise and the temperature. So the more hours we get after sunrise, the higher the temperature goes. That's a positive association. And if I were to draw a line of fit, it would have a positive slope. Because this data does look like it follows a positive slope, we would say that there's a correlation between this data. Not necessarily that one piece causes the other to happen, although sometimes that's true, but there is definitely a correlation between those two pieces of information. The dots are the actual temperatures. So what this is saying is 2 hours after sunrise, the temperature was exactly 61 degrees. And 2.5 hours after sunrise, the temperature was 61.9 degrees. 4 hours after sunrise, the temperature was 64 degrees. And so we can see each one of those temperatures. The line, on the other hand, just describes the overall idea or the overall prediction of what's going to happen. And so now I can look at it and say, what will happen at 10 hours or 10.5 hours after sunrise? And I can begin to look at that line and use it to predict where that temperature would be. Some of you may be asking about the trend line. What if I draw a trend line that's just a little bit different? How do I determine where that trend line goes? Well, there's not an exact science to this, guys. But we want to do the best we can to get a trend line that fits the data. So you're not going to be able to draw a line that touches every point, or it wouldn't be a straight line. So when we draw our line, we want the line to match the data as best as it can. Sometimes this means that we have about the same number of points below the data as we have above the data. But sometimes it means that if most of our points fall in a line down here and we have just a few up here, that those few points up there would just slightly pull our line up a little bit. What I want you to understand is our two lines, your line and my line, are not going to be exactly the same. When we're doing this with paper and pencil, we're not going to get the exact same line ever. But what we will be able to find is our slopes and our y-intercepts should be similar to each other. And in doing that, then we can use that information as a prediction tool. So here we go, drawing our line. What trend line models the data in this scatter plot? Guys, the more precise we can be, the better we're going to be in looking at our information. So here are our key points. Key point number one, when we're talking about trend lines, is we need to draw it. Just like I said before, we want to draw it as accurately as possible. So that means a straight edge. It doesn't have to be a ruler. It could be the edge of your book or the edge of a piece of paper. Or if you have your ID badge handy, that works as well. But again, we want about the same number of points above the line as we have below the line. And we want to draw this nice and straight as we can. So when I look at this data, I might draw my trend line to look something like this. So again, I look and I see I have 3 points above the line. I have 4 points below the line, about the same number of points above and below the line. So I can feel confident with the way that I've drawn that trend line. All right, after we've drawn the trend line, the next thing we're going to do, because it asks what trend line, so they don't just want a picture, they actually want an equation. And so what I'm going to do now is I'm going to pick 2 points. And those 2 points need to be on the line. So will these 2 points be points that they graphed in the first place? Sometimes it is, sometimes it's not. With the trend line that it looks like I have drawn, it doesn't really look like I have drawn a trend line where points would actually be on the line. So I'm just going to choose 2 points that it looks like are on the line. So it looks like I have a point here and maybe up here. It's best if we choose those points a little bit further apart from each other, not right next to each other. We just get a more accurate picture that way. Can they be plotted points? Absolutely. but they don't have to be. They need to be points on the line. So in this case, the 2 points I've chosen is it looks like I've chosen 4, 150, and the other point I've chosen looks like I've chosen 14, 450. So guys, this is where things should start to look familiar. I've got 2 points and I'm asked to write a trend line. I'm asked to write an equation of a line. So to do that, when I'm given 2 points, I'm going to start by finding the slope. So the slope in this case would be 450 minus 150, y minus y, divided by 14 minus 4. So 450 minus 150 would give me an answer of 300. And 14 minus 4 would give me an answer of 10. We always want to reduce our slopes. Guys, in these cases, sometimes our slopes don't turn out to be very nice numbers. They may not be whole numbers, they may be decimals or fractions, and that's okay. But in this case, 300 divided by 10 would give me an answer of 30. Now, I'm going to be real honest. I did this problem just a few minutes ago on paper, and when I did that, I got a slope of 33 and a third. But you'll see, I have to accept both of those answers because they're similar, and it depends on the points that I choose in order what my slope is. So I'm not looking for an exact answer here. I'm looking for, did you draw a line of fit? Did you pick 2 points on that line? And then did you find the slope correctly using those 2 points? All right, from there, once I have my slope, and now I have a point and a slope, I'm going to use my point slope form to write my equation. So I'm going to choose to use this point here. So I'm going to have y minus 150 is equal to 30 times x minus 4. Now, we like to write our slopes or our equations in slope-intercept form, so I'm going to go the 2 extra steps and say that this becomes 30x minus 120. And then I still have the y minus 150 over here. And I'm going to add the 150 to this side, and I end up with an equation of y equals 30x plus 30. And so when I finish this problem, in order to see if it sounds reasonable, I'm going to check 2 things. I'm going to check my slope. So does it seem reasonable that I'm rising 30, running 1? So running 1 would be about halfway here. So rising 30, running 1, that seems reasonable, and you can check it at any point. Second of all, I want to make sure it's a positive slope. So this is a positive 30. It looks like a positive slope, so I can feel good about that. Second of all, I'm going to check my y-intercept. Does it seem reasonable that this line is crossing at a y-intercept of 30? Well, this marking would be 50. My graph looks like that might be a little lower than 30, but it seems reasonable. It's pretty close to what that line is. When I look at my line of fit based on my data, I would say that this is a weak correlation. A strong correlation would be a line that fits and touches almost all of that data, or the data looks like it's in a line. This one's a little more scattered, so it's a little bit more weak, but it still looks like it's forming a pattern, a positive correlation pattern. All right. What kind of trend line in slope-intercept form models this data? So remember, we need to first draw our line. So what kind of line is this one going to have? Are we going to draw a line that looks like that? No, that doesn't fit the data. We need to draw a line that looks like it fits what's happening there. So when I draw my line, this time I'm probably going to draw a line that looks a little bit more like this here. Oops. Didn't seem to get it to draw. So something a little bit more like this. About the same number of points above and below the line as we can get. Again, we're going to choose 2 points. And so in this case, I'm going to choose like 2, I don't know, maybe 69. And then I'm going to come over here and choose like maybe 860. All right, this time when I find my slope, I'm going to take 69 minus 60. divided by 2 minus 8. 69 minus 60 is 9, and 2 minus 8 is negative 6. Reducing that, I'm going to get an answer of negative 3 halves. Again, sometimes we get different types of slopes. It may not look very pretty on these because we're drawing a line of best fit. All right, once I do that, I choose a point. I'm going to choose my 269 here, and I'm going to write my equation. So y minus 69 is equal to negative 3 halves times x minus 2. It did ask for slope-intercept form this time, so this time I'm going to distribute and get negative 3 halves x, and then negative 3 halves times negative 2 is going to turn into a positive 3. So y minus 69 is equal to negative 3 halves x plus 3. I'm going to then add my 69 over to the other side, and I end up with an equation of y is equal to negative 3 halves x plus 72. And so then again, I'm asking myself these questions. Does my slope appear to be negative? It sure does. Does it appear or does it seem reasonable to have a y-intercept of 72? And yes, it seems reasonable. Again, mine looks a little bit lower than that on my graph, but it seems like a reasonable question or a reasonable answer there. All right, last but not least here. This time, all they do is they give me a table full of information, and they're asking us to create a trend line so that then we can use this, as I told you, to predict a speed. So in this case, I'm going to start by drawing my graph. I'm going to look at my x values. X values are here on top. It looks like we're going between 35 and 60. So if you'll remember, that means I can put this little break in my graph. That just means I'm skipping some material in this graph as I'm going. And so in this case, I'm just going to start here at 30, and then 35, 40, and 45, 50, 55, and 60. And that seems to get me what the information that I need. Then when I go to look at my y values are all very small, between 6.6 and 3.8. So I'm just going to come out here to the side, and I'm going to choose to just go by ones, but you could choose to go by 0.5 if you wanted. So I'm just going to say this is 1, 2, 3, 4, 5, 6, and we'll need to go just a little higher and to get 7. All right, so to graph, I'm graphing the point 35, 6.65, so it's going to be up here close to that 7. Then I'm coming to 45.8, so just a little below the 6. 45 is at 5.17, so just a bit above the 5. 50 is at 4.65, so a bit above 4.5. 55 is at 4.23, so again over here. And finally, 6 is at 3.88, so close to the 4. All right, so looking at this, it looks like this is a pretty strongly associated piece of information, strongly associated graph, scatter plot of information. And so I can go ahead and draw a line of fit to the best of my ability here. Now this time my line of fit looks like it hits quite a few of the points on this graph. And so I might actually be able to use points that are on this graph. So let's take a look. Looks like 63.88 I could use. And let's see, it looks like maybe the 45 and 5.17 I could use. Again, there are other points that I could have chosen as well. So just choose the ones that you think work best. All right, so in this case, if those are the 2 points I'm using, the first thing I'm going to do is find my slope by taking 5.17 minus 3.88 and dividing by 45 minus 60. When I do that here, guys, I end up with 1.29 divided by negative 15, which does not come out to be a nice whole number. And in fact, it's negative 0.086. And again, that's okay on one of these types of problems. So then writing my equation, I'm going to choose one of those 2 points. I'm going to choose the 63.88 and start with y minus 3.88 is equal to my slope of negative 0.086 times, times x minus 60. Distributing in, I end up with y minus 3.88 is equal to negative 0.086x, and then negative 0.086 times negative 60 becomes positive 5.16. Last but not least, I'm adding that 3.88 to get the y by itself. And I end up with an equation of y equals negative 0.086x plus 9.04. So I'm asking myself these questions again. Do I have a negative slope? Yes, I do. Does it seem reasonable that my line would be crossing up here at 9? Yes, that seems reasonable. But I still haven't answered the question because now they're saying, how long would it take to download a 100 megabyte file if the internet speed is 75? So think about it. Now that we have an equation, we can predict using that equation. So they're telling me my speed is 75. Down here, I see that the speeds are all x values. And so what I can do is I can now replace my x value with a speed of 75. So y is equal to negative 0.086 times 75. And then I'm going to add 9.04 to the answer. When I do that, I end up with an answer of 2.59 seconds. Or I guess I should say minutes, sorry, because it says how many minutes to download. All right, so what that's telling me is about 2.59. And so if I come back over here and look at my graph, I'd be at 65, 70, 75. Does it seem reasonable that 75 would be just here over 2 seconds? And yeah, that seems reasonable. So I can verify my answer by using my graph. So again, guys, today is not new information. It's just applying that information we have by looking at a scatter plot, but then choosing our 2 points, finding our slope, and then using that slope in one of the 2 points to write an equation. Hope this helps. Hope you are having a great day. Please be reaching out if you've got any questions so that we can help you stay on track with this information. We'll talk to you later. Bye.